This video will be about solving equations with variables on both sides. So when we have variables on both sides, we still start like we do with normal multi-step equations and determine if there's anything to simplify. Looking on the left side, we do have parentheses which we could distribute. So 3 times x is 3x. 3 times -5 is -15. On the right side, we don't have any like terms, we don't have anything to distribute, so we leave it 5x minus 7. So again, we double check anything on the left side now that would combine with like terms. There are no like terms on the left side. We do notice there's like terms on opposite sides, but not on just the left side or just the right side. So when we get to this point, we've simplified everything we can. We have to move one of our variables. So we actually have a couple of options. I'm going to write 2 equations up at the most simplified point so that you can see the 2 options. Now this is a positive 3x if there's no sign in front of it. We assume it's positive. So to move the number itself and the variable together, we can't just divide because dividing only moves the number. We want to move the number and the letter. Since it was positive 3x, we want to minus 3x from both sides. So I could minus 3x from both sides, or I can use the 5x instead. I could minus 5x from both sides. This has a little more flexibility. You can sometimes do one or the other, and they'll both get you to the correct answer at the end. Here our 3x's cancel. 5 minus 3x is positive 2x. Over here, if we're doing it our second way, 3x minus 5x is negative 2x. 5 minus 5x cancels. We get negative 2x minus 15 equals negative 7. So now we're a little more restricted. If we did the minus 3x, now we've got to add the 7 to both sides. We've got to work with this stuff on the same side as the letter because we want to move it away from the letter x. So this one I have to add 7 to both sides, but this time the negative 15 is the same side as the x. So if I had chosen to minus the 5x first, now I've got to add 15 to both sides. So that gives us negative 8 equals 2x, or negative 2x equals positive 8. Now, 2 times x, we would divide both sides by 2. So we get negative 4 equals x, or negative 2 times x, we divide by negative 2. 8 divided by negative 2 is still negative 4. So no matter which way you do it, which one you start with, you would have the same answer. Both of them came out to be negative 4. So you can choose either way. You just have to use one of the variables and add or subtract it to the other side. You can also apply this to the geometry situation of having vertical angles. When you have the angles across from each other, when 2 lines are forming an X, the ones across from each other are equal to each other. If we have 6x plus 3 degrees and 8x minus 21 degrees, these are equal to each other, so I can set up the equation 6x plus 3 equals 8x minus 21. So now we do our opposites. Actually, first, I skipped this because I know I don't need any simplification, but you should always check. Is there anything on the left that could combine or needs to be distributed? There is not. Is there anything on the right that could combine or be distributed? There is also not. So now we need to move one of our variables. I could pick 6x to move, or I could pick 8x to move. It doesn't matter. I usually choose the smaller one, so I'm going to minus 6x from both sides. Since it was a positive 6x, no plus sign was written here, but we know if there's no plus sign written there, it is positive. 6 minus 6 is 0, so that goes away. 8 minus 6 is 2. So we have positive 3 equals 2x minus 21. And I really didn't have to write the plus sign this time, since there's no longer another term in front of the plus 3. So now we do our opposites like we would with our normal equations. We have our variable here. I want to move the 21 away from the x. So I'm going to add 21 to both sides. Positive 3 plus 21 is 24. And that's 2 times x, so I divide both sides by 2. Along with geometry situations, I could also apply this to a word problem. You can buy used inline skates from your friend for $40, or you can rent some inline skates. Either way, you must rent safety equipment. If it costs $3.50 per hour to rent inline skates and safety equipment together, and $1.50 per hour to rent only safety equipment, how many hours must you skate for the cost of the renting and buying to be the same? So if you are just renting skates and safety equipment, the $3.50 per hour is the only amount that applies to you. $3.50 per hour means you would multiply 3.50 times the number of hours you skated, and that would give you your cost. And we want to know when it equals your amount if you bought skates. So now the 40 and the $1.50, those both apply because you bought the skates at $40, and you also have to rent skates for $1.50 per hour, so 1.50 times h. You don't necessarily have to put the 0 there, but since it was written as $3.50, it made more sense to me to just write in the 0, but you don't need to. So we have 3.50h equals 40 plus 1.50h. On the left side, nothing to combine or distribute. On the right side, nothing to combine or distribute. Now this time, we only have one number. We have two variables, so variables on each side, but only not numbers on each side. So we are a little more restricted. I want to, just like you usually move stuff away from the variable, if you only have one number, you want to move the variables away from that number. So I'm going to pick the 1.50 and minus 1.50 from both sides. 3.50 minus 1.50 is 2. And 2 times h, the opposite, is dividing by 2. So the number of hours you would need to skate is 20. You would have to skate 20 hours before buying the skates would be worth it. Next, in this section, you want to be able to prove if something is an identity or it has no solutions at all. So what ends up happening when you have these types of problems is the variables end up going away completely. So let's say we have this problem. On the left side, we can distribute, so we do that first. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Now we do have like terms, the 5 and the negative 12, so we'd bring down the negative 3x. 5 minus 12 is negative 7. And now we're ready to do our opposites. Now both sides have a negative 3x, so it doesn't matter which one we pick, because if I add 3x, it ends up canceling on both sides. The variables are just completely gone now. There's no more letter x. So now we look at our answer and see, does this make sense? Is negative 7 ever equal to positive 7? Well, it's not. So if these are never equal, there is actually no solution to this problem. You can never plug in any value for x and have it work out, have it be a true statement. So I'm going to change this just slightly. So we would still need to distribute the negative 3. We'd still start the same way. We would still combine our like terms. 5 minus 12 is negative 7. We'd still do our opposites and add 3x to both sides. This time, though, we end up with negative 7 equal to negative 7. Well, that is always true. Negative 7 always equals negative 7. They're the same number. So this is when it's called an identity. That means no matter what number I plugged in for x, it would always work. So sometimes they call it infinite solutions, but in this case we're calling it an identity. So when you do these problems, they're usually multiple choice, and they'll have an option of no solution, they'll have an option of identity. There is also the option of one solution. And what that is, again, I'm going to take a very similar equation. This time I'm going to change it to negative 2x, though, on this side. What it is when you go through the process and you get x equals something, that means you have one solution. These beginning steps are the same. We distribute the negative 3, we combine the 5 and the negative 12. This time, when I do my opposites, let's say we add 2x to both sides. Negative 3x plus 2x is negative 1x. Notice this time the variables did not cancel out. We still have a variable here. Add 7 to both sides, we get negative 1x equals 14. And then since there's this negative 1, we do have to divide both sides by negative 1. So we get x equals negative 14. This would be considered one solution. Only number you could plug in and make this work would be negative 14. I do want to point out that 0 is a possible solution. You can have an answer of 0. If we were again to just change this a little bit, if I were to make this a negative 7 instead of a positive 7, when we got to this point, I'm going to erase the rest. When we got to this point and we did the adding 7 to both sides, negative 7 plus 7 is 0. So we might think, oh, this means no solution because we get a 0. But 0 is a solution. 0 is a number. So if I divide both sides by negative 1, I still get 0. 0 divided by negative 1 is 0. This is still considered one solution. Because 0 is a number, it can be considered a solution. So that concludes our discussion on solving equations with variables on both sides.